Multiplying polynomials. So when multiplying polynomials, you're multiplying every term. So when multiplying individual terms, what happens is you will multiply the coefficients, but you will add the exponents. So multiplication changes everything. When multiplying, the coefficients multiply like they're supposed to, but the exponents will actually add together. So for this first example, 3x times 5x, we would do 3 times 5 to get 15. And when you multiply x times an x, you're really adding together these little invisible exponents. So this would be x to the 1 plus 1, which would be 2. So 3x times 5x is actually 15x squared. On the second example, 2x squared times 4x, you would do 2 times 4, which would make 8. And then x squared times x to the first would be x to the third, because we add together the 2 and the 1. Now, there's many different kinds of multiplication. So the first kind we're going to talk about is multiplying a monomial times a binomial or a trinomial. Basically, what this means is something with one term times something with two terms or three terms. Really, all this is distribution, just like you've done in the past, except instead of only distributing a number, you are now distributing a number and a variable at the same time. So for number 1, we're going to multiply 2x times 3x. Well, 2 times 3 makes 6, and when we do x to the first times x to the first, we get x squared. Then we have to multiply 2x times 4, just like normal. Well, 2 times 4 makes 8, and because this one does not have an x on it, we would simply just drop the x down. 2x times 4 creates 8x. Let's look at example 2. So with example 2, again, you would have to distribute. Negative 4x squared times a 2x. So negative 4 times 2 makes negative 8. X squared times x, you're going to add the exponents together. So 2 plus 1 is x to the third. And then negative 4x squared times a negative 5. Well, negative 4 times negative 5 is positive 20. X squared times something without an x is just x squared. Now, we say that we're done. This is the final multiplication because there are no like terms here. 8x to the third and 20x squared cannot actually be added together because they're not like terms. So this is as simple as we can go with this problem. So I want you to pause the video and I want you to try number 3 on your own. You're going to be distributing just like you would if you're only multiplying by 9. Pause the video, try number 3. And here's your simplification for number 3. Multiply the 9x to every individual term. Make sure you multiply the coefficients, but add the exponents together. Now let's look at number 4. So number 4 is the same idea, but now we've got two variables instead of just one. So we're still going to be distributing. So we're going to multiply in negative x squared y times 3x squared. Well, remember there's really a negative 1 right here. So negative 1 times 3 is negative 3. Now you have to take these in individual pieces. X squared times x squared means add your exponents, so you get x to the fourth. Y has no y on this term, so we're just going to drop the y down. So negative x squared y times 3x squared is equal to negative 3x to the fourth y. And then we do it again. We're going to have to distribute negative x squared y to a negative x y squared. So again, negative 1 times negative 1 is positive 1. X squared times x, we're going to add the exponents, so we get x to the third. Y times y squared, we get y to the third. And then we do it one final time. Negative x squared y times 5. Well, negative 1 times 5 is negative 5. And there are no variables here, so x squared y will just tag along with the 5. And then again, make sure you don't have any extra like terms that you can combine. So we have x to the fourth y, x to the third, y to the third, x squared y. So none of those are like terms, so this is as simple as this problem will be. Now let's look at the other kind. We can have a binomial times a binomial. This is something with two terms times something with two terms. So the way we approach one like this is it's actually double distribution. So what happens is you're going to multiply this first term times everything, and then you multiply the second term times everything. That's why it's called double distribution. So you're basically doing distribution twice. So let's start with the first one. So 2k times 4k, 2 times 4 makes 8, k times k makes k squared. 2k times -3 makes -6k. And then you continue by starting over, and you do the 1 times 4k minus 3. So 1 times 4k is 4k, and 1 times -3 is -3. And that's it for the multiplication. So what we've done is we've kind of ignored the 1 and we've multiplied in 2k. Then we ignored the 2k and we multiplied in 1. So it's kind of like what happens is it looks like this. It's 2k times 4k minus 3. And then it's also a positive 1 times 4k minus 3. So that's actually what you've done is you've taken this guy times the first and this guy times this. Now that you're here, okay, well, let's think about what this means. I need to see if I can combine anything together. And so I see -6k and 4k are like terms. So I can add -6k and 4k together to make -2k minus 3. So this is the simplified version of this multiplication. So this actually took an extra step. Now let's look at example 6. Let's try example 6 by breaking it up this way first. So what we're going to do is we're going to take -3h times this second polynomial, 2h minus 5. Then we're going to take positive 3 and multiply it to the same polynomial, 2h minus 5. So maybe this is slightly easier to understand what's going on. And so now we're going to basically distribute twice. So -3h times -h is -6h squared. -3h times -5 is positive 15h. Then 3 times 2h is 6h. And 3 times -5 is -15. So again, you have finished the multiplication. Now we're going to see if maybe we can simplify this further by combining any like terms. And so we see that 15h and 6h are like terms, so we can add those together to make 21h, and everything else will just tag along. And so this is the multiplied trinomial from those two binomials. I want you to pause the video and try example 7 on your own. And here's your solution for example 7. Now let's look at example 8. So we have 3x plus 4 all to the second power. So we have to be careful with ones like these because I know what's going to happen is most people think, okay, well, I'll take 3 and square it, and then I'll take 4 and square it, and you get something that looks similar to this. However, that's not quite the case. Think about what it means to actually square something. When you square something, what happens is you take that thing times itself. So we really have something that looks more like 5 and 6. We have the same thing multiplied to itself. Now that we have spread apart that outside square, now we can do the multiplication like we've done before. We'll do 3x times the 3x plus 4, 3x times 3x plus 4. Then we'll do 4 times 3x plus 4. So plus 4 times 3x plus 4. And now we can do the distribution. 3x times 3x is 9x squared. 3x times 4 is 12x. Then we have 4 times 3x makes 12x. And 4 times 4 makes 16. And when we look for any like terms, we see that 12x and 12x are like terms. And those actually add together to create 24x plus 16. So as you can see, there are some similarities. If you had done 3x and squared it, you would have had 9x squared. 4 squared would have given you 16. But what you would have been missing is you would have been missing this middle piece right here in the center of 24x. So when you see that you have a binomial squared, expand it out and then do multiplication. Now let's talk about what it looks like if you have a binomial times a trinomial. So 2 terms times 3 terms. You can do this a couple ways. You can either think of this as double or triple distribution, or you can break it apart like we did up here at the top. So I'll do it both ways. So the first way, we're going to break it up. So I need to do 4r squared times 2r minus 1. So 4r squared times 2r minus 1. then minus 2r times 2r minus 1, then 5 times 2r minus 1. So we've broken it up now into 3 pieces instead of just 2. And now we're going to do the individual distributions. So 4r squared times 2r is 8r to the third. 4r squared times negative 1 is negative 4r squared. Now for the second distribution, negative 2r times 2r is negative 4r squared. Negative 2r times negative 1 is positive 2. And then the third, 5 times 2r is 10r. 5 times negative 1 is negative 5. So similarly to the binomials, we are now done with the multiplication. We simply need to see if there's anything that we can add together, combine like terms. Well, negative 4r squared and negative 4r squared have like terms. 8r to the third does not. So negative 4r squared and a negative 4r squared combine to make negative 8r squared. Oh, this should be positive 2r. I apologize. So here's where it came from. Negative 2r times negative 1 is a positive 2r. So 2r plus 10r is 12r. And then this negative 5 here does not have a like term. So negative 5 will just drop. So this is the multiplication of the polynomials from the top, the trinomial times the binomial. I want you to try example number 10 on your own. And here's your solution for example number 10. So here's some other polynomial multiplications. So there's a couple examples here. So the first example 11 has an x and a y. Example 12 has a single variable, but it's a trinomial times a trinomial. This one will work exactly the same way as the example number 10 did, except for the fact that what you're multiplying here will have 3 terms instead of 2. So for number 11, let's look at this one. So number 11 works very much like regular binomial multiplication. So 2x times 2x minus 3y. 2x times 2x minus 3y. Then positive 3y times 2x minus 3y. And then we multiply. So 2x times 2x makes 4x squared. 2x times a negative 3y, well, 2 times negative 3 is negative 6, and x times y is just xy. Because we can't actually add the exponents because they're not like bases, so we have to leave them at just x times y. We can't really do anything else with it. 3y times 2x is, again, 2 times 3 is 6. Now, y times x is technically yx. But remember that multiplication doesn't really matter what order you multiply in. So yx and xy are exactly the same thing, and we like it in alphabetical order. So when you have y times x, we're going to write it as xy. Then 3y times negative 3y is negative 9y squared. Now that we have completed the multiplication, we're going to look for like terms. So negative 6xy and 6xy are like terms. So we have 4x squared plus 0xy minus 9y squared. Well, we don't really need the 0xy because 0 times anything is always a 0. So what this simplifies down to is 4x squared minus 9y squared. Pause the video, see if you can try example 12 on your own. Here's your solution for example 12.